Alright guys, in today's video we are going to talk about triangle midsegments and the triangle midsegment theorem. So first of all, a midsegment of a triangle is a segment that connects the midpoints of two sides of the triangle. So if we look at our image here, we can see that segment DE is the mid segment because D is the midpoint of segment AB and E is the midpoint of segment BC. We know it is the mid segment because again we have congruent tick marks here, so this tells me that AD is congruent to DB and that BE and EC are congruent. So the triangle midsegment theorem states that if a segment joins the midpoints of two sides of a triangle, then the segment is parallel, so we mark that on our triangle with the little arrows, to the third side and half as long. So in the diagram below, if segment DE is a midsegment of triangle ABC, then DE is parallel to AC and half as long, which again can be represented two separate ways, and I always like to have both. We have DE is AC divided by 2, so it's saying DE is half as long as AC, or backwards, AC is twice the length of DE. Let's pause here for a moment and go ahead and make sure our copies are filled in. So for the practice problems today, we're going to focus on our even problems. So for number 2, it says to identify all pairs of parallel segments. So what I'm going to do is I'm going to focus on just highlighting them simply because marking the arrows will be difficult on the outside triangle. So first off, we know that J, K, and L are midpoints because J is the midpoint of GF as indicated by these tick marks. L is the midpoint of FH. And K is the midpoint of GH. So the first thing I want to do is go ahead and highlight all of my midsegments. Again, remember those are the lines that connect the midpoints. So since we have J, K, and L are our midpoints, we know that JK is a midsegment. We know that KL is a midsegment. And we know that JL is a midsegment. And then they are parallel to the segment across from them. So let's look at JK. All right, so segment JK is parallel to segment FH. KL is parallel to GF. And finally, and segment JL is parallel to segment GH. All right, moving on to number 4. If F, G, and H are the midpoints of the sides of triangles CDE, and they tell us that FG is 9, GH is 7, and CD is 24, we need to find each measure. So it wants us to find CE, DE, and FH, and then it wants us to find the perimeter of the triangle. And remember, perimeter means the distance around the outside edge. All right, so the problem does tell me that F, G, and H are the midpoints of the sides. So first I'm going to mark CE's midpoint being F. So that's going to tell me that CF is congruent to FE. And then H is the midpoint of DE. So we're going to mark EH congruent to HD. And then finally CG is congruent to GD because G is the midpoint of CD. All right, so first I went ahead and added all my tick marks. Now I'm going to highlight the corresponding midsegments. So CE midsegment is GH. They are parallel. The midsegment that is parallel to DE is GF. And then the midsegment that is parallel to CD is going to be FH. Now they do give us some very important information. They tell us that FG is 9. They tell us that GH is 7. And that CD is 24. So now let's find each of these. So first, let's go ahead and do CE, length of CE. So we're in relation to GH. GH is half the length of CE, or if you remember, we can take the midsegment and multiply it by 2, okay? Which means we're going to take 2 times 7, which is 14. All right. Up next, DE. DE is right here. It is parallel to FG. So that's going to be 2 times FG, which is 2 times 9, which means the length of DE is 18. Now we have enough information to get the perimeter, but let's go ahead and find FH. FH is the midsegment, so it is half of the length of CD. So we're going to take CD, divide it by 2, which means we take 24 divided by 2, and that gives us a length of 12. So for the perimeter of triangle CDE, we need CD, which is 24, CE, which is 14, and DE, which is 18. So 24 plus 18 plus 14 is 56. And they didn't give me units, so I don't have to do units. I'd recommend that you pause here and make sure you got all this information copied. All right, number 6, find the value of x. So what we see here is we have a midsegment, the 6x plus 31. Again, we know it's a midsegment because of these tick marks right here and these tick marks right here. So that tells me that this base is going to be twice the length of the midsegment. So let's go ahead and do that. So the way we do that is we're going to take this midsegment and we're going to multiply it by 2. So that's 6x plus 31 will be equal to 19x minus 36. So the first thing I'm going to do is I'm going to distribute the 2. So that's going to be 12x plus 62. And you never have to do this, but I'm just going to show you again. I'm just combining these numbers right here. Okay, so that's multiplying those. And that is going to be equal to 19x minus 36. So what I want to go ahead and do is I want to add 36 to each side of this equation. Alright guys, so I just realized my microphone had been muted, so I deleted that part of the video, but I'm not going to retype it. So what I did was I added 36 to each side, and I got 12x plus 98 is equal to 19x. And then I subtracted 12x from each side, which gave me 98 is equal to 7x. And then I was going to divide when I realized that I didn't have any microphone. I was going to divide both sides by 7. Sorry, I just can't believe that happened. Again. And when I divide 98 by 7, I get 14. So my final answer is x equals 14. And I'm just going to go ahead and highlight that. And because of that slight mistake, go ahead and pause here and make sure you get this copied down. All right, number 8, it wants us to find RT. In order to find RT, we first have to find X. So we see that PQ is a midsegment of this triangle. And again, we know that's a midsegment because of our tick marks right here. Okay, so again, that tells me that PQ is parallel to RT, and it's half as long. So what we're going to do is we're going to solve this. All right, so we need to write a formula. So we know that RT is equal to 2 times PQ. All right. We're going to substitute in the information we know. So we know that RT is 23x minus 6. And that's going to be equal to 2 times 15x. Oops. 2 times 15x minus 17. And then we're going to distribute. So we have 23x minus 6 is equal to 30x plus 34. I'm sorry about that. I mean minus 34. I was sitting there far too long trying to figure out what was going wrong. All right, so now what I want to go ahead and do is I want to add 34. Now I want to add 34. And that's going to leave me with 23x plus 28 is equal to 30x. And now I'm going to subtract 23x from both sides. That leaves me with 28 is equal to 7x. I'm going to divide both sides by 7, and that will leave me with an x value of 4. Okay, but it didn't ask me to find x. It asked me to find RT. So let's go ahead and do that. So RT is equal to 23x minus 6. And then what we're going to do is substitute in 4, and we get 86. All right, guys, let's pause here. Take a break. Go get a snack. But make sure your notes are copied. All right, moving along to number 10, that asks us to find the measure of each missing angle. So the first thing we know is we can see based on the tick marks right here and these tick marks right here that this line right here is a midsegment. What that indicates to us is that the midsegment, again, right here, is parallel to the base, or the side that it's not touching. So knowing that information, we can find the angle measures because now we have parallel lines cut by transversals, and we have 2 transversals to work with. So what I'm going to do is I'm going to highlight my 2 transversals, just like I always do. So transversal number 1 and transversal number 2. And I'm going to go ahead and highlight the other parallel line in the same color that I highlighted the midsegment. All right, so these parallel lines are in a slightly different orientation than we normally see them, and that's great because that means we have to think about it in a completely different way. So let's go ahead and look at these angle measures. So first of all, I can see that angle 2 forms a linear pair with this 127-degree angle. I can also tell that 127 and angle 1 are same side interior angles, as they are on the same side of the orange line, and they are both inside the blue lines, which are my parallel lines. And then angle 2 and angle 1 would be congruent to each other. So in order to find both angle 2 and angle 1, what we are going to do is take 180, and we are going to subtract 127. And that gives us 53 degrees. So that tells me that both angle 1 and angle 2 are 53 degrees. Now, I do not yet have enough information to do angle 3, but I do have enough information to do angle 4 and angle 5. If we look at both angle 4 and 5, they are going to be related to the 59-degree angle here. So first of all, angle 4 is in the same relative location as the 59-degree angle, which makes them corresponding angles. Angle 5 and the 59-degree angle are same side interior angles, so again, they're going to equal 180. So we already know that angle 4 is 59 degrees because it's a corresponding angle to the 59-degree angle. And then angle 5, again, can be found by subtracting 59 from 180. And that gives us a 121-degree angle. And finally, now we have enough information to find angle 3. There's several ways we can do it. We can remember that 127 is an exterior angle to this triangle, so it would be equal to 4 plus 3, angle 4 plus angle 3. And that would mean I just take 127, and I'm going to subtract angle 4, which is 59. And I'm going to get 68 degrees. And then, of course, to check our work, we can make sure that the three angles, angles 2, 3, and 4, which are 53, 68, and 59, we can make sure that those add up to 180, 53, 68, and that equals 180. So at the very least, our answer makes sense. Pause here for a moment and make sure you get these copied into your notes. Okay, number 12, we're going to find the value of x. Again, we see that the line right here in the middle is a mid-segment, once again as indicated by the tick marks right here and right here. So what I'm going to do is I am going to highlight my mid-segment and the base, reminding ourselves that they are parallel because, again, the mid-segment is parallel to the base and half as long. And again, we're looking at these as if they are parallel lines cut by a transversal, but we only need to worry about this transversal at this point. And we can see that they are in the same relative location. So they're on the same side of the transversal, and they are both in the left-hand side of the angle, okay, because we only have left and right in this case. So what that indicates to me to solve for x is all I need to do is go ahead and set those equal to each other. So that is going to be 10x minus 11 is equal to 7x plus 4. And for this problem, I want to go ahead and add 11 to both sides, which gives me 10x is equal to 7x plus 15. And then, of course, I'm going to subtract 7x from both sides. And that's going to leave me with 3x is equal to 15. And then I'm going to divide both sides by 3. So I have 3x divided by 3 equals 15 divided by 3. And that will give us a final answer of x is equal to 5. And that is what they wanted us to find, so we are done with this problem. Pause for a moment and make sure you get this one copied into your notes. All right, last one. They want us to find the measure of angle CBF, which is going to be this angle right here. So again, the first thing we're going to see is that we are given tick marks indicating that F is the midpoint of segment BD. And these tick marks here indicate that is the midpoint of segment CD. Given that information, that tells me that segment EF and segment CB are parallel. And that is because segment EF, since it connects the midpoints of two sides, is going to be a midsegment. So what we're going to be doing is the same thing we did on the previous problem, just with one extra step. We're going to look at our parallel lines. This is our transversal. We see that angle CBF and angle EFD are both on the right-hand side of the parallel line, and they are both on top of the transversal. So there's one inside, one outside, same side of the transversal. They're in the same relative location. Therefore, they are corresponding angles. Now, because they are corresponding angles, we can say that the measure of angle CBF is equal to the measure of angle EFD. And again, that's because they are corresponding angles. So now we're going to go ahead and do the substitution. We're going to set 9x plus 2 equal to 15x minus 52. All right, now I'm going to add 52 to both sides. All right, and that's going to give me 9x plus 54 is equal to 15x. Now I'm going to subtract 9x from each side. And that leaves me with 54 is equal to 6x. We're going to divide both sides by 6. And that gives me an answer of 9 is equal to x. But again, in this case, that's not what they asked me for. They asked me for the measure of angle CBF, which is 9x plus 2. So what we're going to do is we're going to go ahead and substitute. We're going to substitute 9 in for x. We're going to add 2. And 9 times 9 is 81, plus 2 is 83. So the answer is that the measure of angle CBF equal to 83 degrees. So that's going to wrap it up for this particular set of notes. Make sure you get these copied in and also that you answered the questions in Google Classroom. See you later.